All right, in seventh grade today we are starting topic 8. So we are going to be looking at solving equations. And to do this, there are a couple things that you need to know before we get going. So for starters, at the top, make sure that you have your name and your class. So you can just put your hour, either 5th or 7th on here, and the topic. So we are in topic 8, solving equations. But in addition, I would also like for you guys to jot down up here the learning goal. And our learning goal is to use inverse operations to solve equations. So that is going to be a key term that we are going to be talking about a lot, so you're going to want to become familiar with it. Let me make this smaller so you can see it better and copy it down onto your note sheets. But that is the process that we are going to be using over and over and over in this topic, and really here on out through the rest of your math careers. So we need to make sure that we understand why we're using inverse operations and what they are and how to use them to accomplish our goal. So let's check out, we have 2 sections of this note sheet that we're going to look at today. So let's check out the first 2 sections. We're just looking at very simple equations right now. We call these one-step equations that we're looking at. And in addition to one step, we're going to look at kind of a special case equation that has fractions in it. But both of these only require one step to solve, which is why they're a great place to start. So the first thing that we need to know about solving equations is whenever we see the word solve, that tells us that we need to tell the value of the variable. We need to find that value. So if you ever see a direction with the word solve in it, you know that there's going to be a variable, and we need to tell you what number that stands for, what's its value. So as I look at this first equation here, m plus 12 equals 10. A lot of us can probably look at this and reason through it and say, okay, m stands for a number that when I add 12 to it, I'm going to get 10. So we might be able to visualize what this letter M stands for. If I'm going to add 12 to a number and I'm going to get 10, I'm really ending up with less than what I added. So I'm thinking, okay, M must be a negative number. But even though we might be able to do this in our head or look at this and know its value, what we're working on now is learning the proper steps so that we are able to solve more complex equations. So even though you can do this in your head, you will need to show your work on all of these, and that's just going to build that habit of showing your work so that you understand the process and you can apply it to harder problems. So when we say solve, and I need to find the value of this variable, to do that I need to get it all alone so that this equation doesn't say m plus 12 equals 10, but it tells me m equals, and then I find the number. That way I know its value. So ordinarily when we are um, evaluating expressions like we have been going through the order of operations, or PEMDAS, in this order. But when we are solving equations, we talked about our learning goal being to use inverse operations. So when I use inverse operations, that means that I am going to be undoing things. So I'm actually going to go backwards through the order of operations to undo, because I'm doing the inverse. I'm doing kind of the opposite. So as I solve for m here, I want m all by itself on this side of the equation because my equation has to be balanced. Think of it like a balance scale. This side has to have the same value as 10 on this side. So what I'm going to do is I'm going to get m by itself by getting rid of this 12. So I have to think, okay, what's the opposite of plus 12? Well, that would be minus 12. and whatever I do to one side, I have to do to the other. So I subtract 12 from both sides of my equation. When I talk about sides, I'm using the equal sign as my divider. So I subtracted 12 from the left side and I subtracted 12 from the right side. Well, 12 minus 12 is 0, so the only thing I have left on the left side of my equation is just this m. I'm going to bring down my equal sign, and now I'm going to do 10 minus 12, which gives me negative 2. Now I have the variable all by itself, so I know that m equals negative 2. And to check my work, I can substitute negative 2 back into my equation. So negative 2 plus 12 equals 10. And let's make sure that's right. Is negative 2 plus 12 10? So think about your number line. If you're at 0, you're going to go left 2 to start at negative 2. Now I'm going to move right 12 units. That is going to land me at positive 10. So this checks out because 10 equals 10. So let's try that again on number 2. Again, looking at my equation and saying, okay, I need g all by itself so that I know what g equals. So what do I have to get rid of on this side of the equation so that g is alone? Well, I need to get rid of a minus 9. What's the opposite of minus 9? The opposite of minus 9 is plus 9. Whatever I do to one side of the equation, I have to do to the other. So I'm also going to add 9 to the left side. Okay, now I have negative 2 plus 9. These are different signs, so I find the difference. My larger number keeps the sign. So negative 2 plus 9 is 7. On the right side of the equation, I have a minus 9 and a plus 9. That cancels to 0. So all I have left over here is g. Now I know that 7 equals g. I found the value of my variable, so I'm done. But let's go ahead and check our work just to make sure it checks out. So if I put this 7 back in my equation for g, I'm going to rewrite this whole equation, but I'm going to put 7 instead of g. So now I have negative 2 equals 7 minus 9. Well, that works out nicely because 7 minus 9 is negative 2, so my equation stays balanced. Let's try number 3. We've looked at an equation where I'm adding a number to my variable. We've looked at an equation where I'm subtracting a number from my variable. But now let's look at an equation where I'm multiplying a number by my variable. When I see negative 7y, I know that this means negative 7 times y. So if I want y to be all by itself, I have to undo this times negative 7. So I think to myself, what's the opposite of multiplying by negative 7? Well, that would be to divide by negative 7. So if I divide this side by negative 7, I have to do the same to the other side. So negative 7 divided by negative 7 cancels to 1. And 1 times y is y. So that's all that I have left on this side of the equation. And over here I have a negative divided by a negative, which is going to give me a positive. And when I do negative 91 divided by negative 7, I'm going to get positive 1 because 7 will go into 9 one time, and it gives me 2 leftovers. So 7 will then go into 21 3 times. So I end up with positive 13. And I should double check my work and substitute 13 back into my equation. So if I do negative 7 times positive 13, I should get negative 91. A negative times a positive makes a negative, so my equation checks out. All right, and as you've probably guessed, our last one, I'm going to look at an equation where I'm dividing the variable by a number. So as I look at this equation, I have a divided by 9 equals negative 4. So to solve an equation, I need to find the value of the variable. So that means I need to get a all by itself. So I need to get rid of or undo this divided by 9. So the opposite of dividing by 9 is to multiply by 9. So I'm going to multiply the left side of the equation by 9, and I'm going to multiply the right side of the equation by 9. This works out nicely because these 9's will cancel, and all I'm left with is a. And on the right side of my equation, I have a negative times a positive, which gives me a negative, and 9 times 4 is 36. Let's go ahead and check our work and substitute my solution back in for a. So I'm going to rewrite my equation, putting negative 36 in for a. And when I divide negative 36 by 9, I do in fact get negative 4. So this equation stays balanced because negative 4 equals negative 4. So for each equation, I used one step. To undo addition, I use subtraction. To undo subtraction, I use addition. To undo multiplication, I use division. And to undo division, I used multiplication. One step on each equation to solve, because I only had one number to get rid of in order to get the variable all by itself. One other thing we can do in one step is get rid of fractions, but this takes a little more thought. So I have to get rid of a fraction by multiplying by the reciprocal, and you've heard us talk about this before. So this isn't anything new, it's just looks a little more complex when we're first looking at it, but I'm doing the exact same thing. I need to solve this equation, so I need to find out the value of the variable. What does x equal? To do that, I need to get x by itself. So if I need to get rid of this fraction so that x can be all by itself, then I'm going to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. And whatever I do to one side of the equation, I have to do to the other. So I'm going to multiply both sides of this equation by 3/2. And that's perfect because that will cancel my fractions. So all that's left over here is just the x. On the right side of my equation, I have 10 times 3, which is 30, divided by 2, which is 15. Let's double check our answer just to make sure that we solved correctly. So I'm going to substitute my answer back in for x. So I have 2/3 times 15 equals 10. So 2/3 times 15, I'll do 2 times 15 is 30. 30 divided by 3 is 10, and that works out. 10 equals 10. On number 6, same thing. I need to get w by itself, so I need to get rid of 4/9. To get rid of a fraction, I multiply by the reciprocal. The reciprocal of 4/9 is 9/4. Whatever I do to one side, I have to do to the other. So over here, those cancel. That's why I multiplied by 9/4. So all I'm left with is the w. On the right side, I have a -8 times -9, which is -72, divided by 4. So I have a negative divided by a positive. That's going to give me a negative. And 72 divided by 4 . 4 will go into 7 once, give me 3 leftovers, and when I bring down the 2, 4 will go into 32 8 times. So this is -18. And if we want to double check our work, then I can substitute my answer back in for w. So I have 4/9 times -18 equals -8. So this is supposed to be a 4. So I have 4 times -18, which we already found is -72, and -72 divided by 9 is -8. So this equation is balanced. -8 equals -8. On number 7, I have -6/5 k equals 12. If I need to know what k equals, I need to get it by itself. To get k by itself, I have to get rid of -6/5. So this time, I'm going to multiply